So 5 shouldn't have been too evil.
5 for the front?
Yeah.
Yeah, okay.
Right? What'd you guys get for this one? X squared is x times x.
X plus 3.
Plus 3 minus 5?
Yeah. The bigger one's got to be negative, so it has to be negative. I love it. Don't make it equal to 0. That's so... Everything is 0. It's like, holy shit. And then this guy...
That's kind of tricky.
So what's his first step on this one?
Multiply the first and the last one.
Good. A times negative 6, negative 48. I don't have to start with a list of factors of 48 if I don't want to, especially if I fact and I'm like, I can't see it. What's going to be true about the two numbers? Are they going to be the same sign?
No.
Opposite signs. So they actually have to subtract to be 13. So here's two numbers that subtract to be 13. Or, negative 15. What is negative 15 times 2, though?
30.
Not the right thing. What else subtracts to be, or, adds to be negative 15?
16 and 3.
And negative 16 times 3 is negative 48. Not the factors I would think about immediately. Right? So now I can rewrite this as... So really, I didn't change anything. These two are exactly the same. Because negative 16 plus 3 is negative 13. But what I've done is I've organized it so I can use a certain method. Right? Of course, it's grouping. So out of these first two, you can take out a
8.
8
8x.
x.
X
X minus 2.
plus 3.
Yeah, 3.
X minus 2.
These are the same, meaning I've done it right so far. So then I can take the x minus 2 out, and I'm left with
8x plus 3.
8x plus 3. And then everybody's favorite. That's the old cautionary tale about don't just go off of this guy, go off of everybody. I can't cut everybody in thirds, at least not easily. What's the cube root of 50? No thank you. So I can't cut everybody in thirds, but thank God, what's the first thing I always do though? GCF.
2x.
They're even, so 2. This guy got 1x, so I can take a 1x out. And this guy, of course, is squares. 2 terms, so it can only be squares or cubes. I can cut everybody in half, so
2x minus 5.
yeah,
2x plus 5.
there you go. Half, minus plus, or plus minus, it don't matter. Is that cool? How do I know I'm done? Because every factor, nothing can be done with it. That's how I know I'm done. Okay. Now, part B is where I actually get answers, because they're actually equations.
Yes.
The first one, it's so easy to just start multiplying, because you're so programmed to do that. But the first one, most of the work's been done for you already. They're already factored, right? And it's equal to 0. So what can I do then?
Equal to 0.
Yeah. So I got, this is B1, x minus 2, 3x minus 4, is that what?
Yes.
So either this is 0, whatever this number is, it could be 0, or this has got to be 0. So either x is 2, or x is 4/3. I like it. Yes,
So on the test or quiz, just circles the answer?
please, yes.
Okay.
Yeah.
Or square, right?
Or square, exactly.
Okay.
Or trapezoid. Somehow indicate what the answer is. Especially if you do work and then you check, and I'm like, what the shit's going on?
Can you do the
Circle
visual-
your answer. Say again?
I'm sorry, can you do the visual part of 3x minus 4 equals 4 with 3? I just put it.
How do you mean? Oh, show the steps?
Yeah.
How do you solve for x?
Oh, okay.
Add 4, then divide by 3.
Okay.
Yeah, cool. I like it. Mark, you want to, it's not a bad
Is now
time.
a good time? Okay,
Yeah,
cool.
go.
I never know when I walk in if I'm totally interrupting a section or not.
Now we're going to run by there too, but since you came all
Yeah.
the way out here,
Yeah.
go for it. This is Mark from the Math Study Center.
Hello.
Tell you a little bit.
So they haven't been by yet?
Not yet.
Okay. So I'm not going to go ahead and give you guys the rundown of where it is, since you guys are all going to be taking a field trip at some point. What I will say is that my name is Mark. I've worked there for about 6 years now. And I definitely feel like it's a great resource for students, and I've used it myself. Our hours for the summer are going to be Monday through Thursday from 8 in the morning till 5 at night. And the way it works is you guys can just kind of show up. It's as like a drop-in center. You don't need to make any sort of appointment or anything. You'll see when you go over there, there's tables and chairs available, so you guys can just go ahead and kind of find a place to sit, get stuff out, start working on things. Do they do my math lab, or is it?
Some of them, it's
Okay.
optional.
Okay, well, we do have computers available that you guys can sit down and sign up, sign in on and all that good stuff. So we try to make sure that we have as many resources available as possible. If you guys are working and you get to a point where you get stuck, and you see one of the math tutors just walking around, feel free to just let us know, hey, I got a question, and we'll be glad to help you. If you see that all of us are available, you'll see, or unavailable, excuse me, you'll see a small whiteboard on the left side of the room, numbered 1 through 30. What you'll do is you'll just write your name down in the next available spot. You'll hear tutors calling out names. When we call out yours, just let us know where you're at. We'll come over, we'll introduce ourselves, and we'll say, hey, how can we help you? We do ask that you try to limit your questions to about 5 minutes or so. And the reason why for that may seem like a short amount of time. You're like, is because if you look around the room, imagine if every single one of you showed up. You'll see when you guys go in there, that you'll fill up seats very quickly. Each one of you would want help, and we want to make sure that we can be as fair as possible to every student. So that's why we put kind of that time cap. However, let's say we spend about 5 minutes with you guys. You feel good, do a couple more questions, and you get stuck again, ask for help again. There's no rule that says you're only allowed to ask for help so many times. There's no rule that says you're only allowed to spend so much time in the Math Study Center. Now, if you're still in there at 5, we will kindly ask you to leave because we want to go home too. Hopefully that makes sense. Now, I also know for myself, I don't know if anyone can identify with this, but I sometimes leave the house in a rush and get to school and I'm like, oh, I forgot stuff. If that's you and you want to work on homework, maybe like after class or a little bit before, we have books and we have calculators that you guys can check out and use while in the Math Study Center. Unfortunately, we do not allow you guys to check them out and walk around with them. But while you're in the Math Study Center, they're there and available for you guys to use. All we ask is that you use the student ID to exchange so we can keep track of who has what. Does that make sense? Are there any questions? Yeah, the only thing I would suggest, and I imagine your teacher would kind of double down on this, is I would check it out maybe either later today or sometime in the next 2 days or whatnot. You might find out that, hey, it's not a resource you need, and that's fine. I won't take it personally. I'm cool. But if you do find out that you need that, it's better to find out early on rather than 3 or 4 weeks down the line because things move a little bit faster in summer school, right? So just my 2 cents.
Cool.
Yeah.
Smart.
Good job. See you all around.
Aw, that's nice. Let's see. Okay. So that was that one. It's really, really easy to just, your brain goes, oh, I gotta FOIL that stuff out. Because like I said, you've been programmed to do that. Sorry, done for you. Part 2 has not been done for you yet. And part 2 is a little evil with the numbers, if you're not careful. It can't be 4 and 6. Because to make negative 10, they'd have to both be negative, and then they don't multiply to be negative 24. So what is it?
2 and 12.
Yeah, 2 and negative 12. Because they add to be negative 10, and they multiply to be negative 24.
Does it matter? Like, why did you put negative 12 by?
Doesn't matter. Always. I have to pick a way to do it, but it could be either way, because multiplication is commutative. I like it. When I say that word, you guys remember what that means? Commutative? Commutative property is A times B equals B times A. So 7 times 8 is the same as 8 times 7, right? Cool. So what 2 answers do I get here? Good. I like that. Kick ass. And as always, you can plug them in to check it. And then number 3, I love number 3 because it reminds you that just because we learned a new way to solve certain equations doesn't mean you suddenly have to do that way. What's the only reason we've been factoring this stuff to solve it and not doing it the way we used to? Because this stupid thing here, right? If that wasn't there, I'd just add the 24, divide by the 10, right? I'd just get my x's on one side, numbers on the other side. So on part 3, that kind of thing should happen to you. So of course here, what do you do first?
Multiply.
Yeah. So you get 2x squared minus 3 plus 4x minus 2x squared. That's interesting. And now you just solve it the old-fashioned way. There's no higher powers on your x. All your x stuff is like terms. Get your x's on one side, numbers on the other side. So now I can, if I wanted to, I can, it doesn't matter. I can add 3x. I can add 3. So then I get 7x equals 8. And then divided by 7. You could have went the other way, got 2 negatives, they're going to cancel anyway. So we all should agree on 8 over 7.
So negative 8 divided by negative 7.
The negatives cancel.
Okay.
Yep.
Makes sense.
I like it. Bless you. Is that decent? Is that all right? No, what happened?
Okay, so I get the distribution.
Mm-hmm. And then these kill each other.
Right, I got that.
Cool.
I get the 3, how it kills itself, but I don't know where the other 3 went.
Hold on. So let me write down. Here's what we got after the x squared stuff dies, right?
Right.
So now I just decided to add 3x and add 3.
Okay.
Get my x's on one side.
Okay.
Numbers in. You could have subtracted 4x instead and subtracted 5.
Okay.
It would still work the same way. Divide by negative 7. The negatives cancel. 8 sevenths. Yep. I like it. Once the x squared terms goes away, you can just treat it like chapter 2 equation. Right? You don't have to factor. I like it. Okay. So I like to put that kind of problem on to remind you there's a reason we do it this way, and if that reason goes away, then don't do it this way. Like, yeah.
How'd that reason go away again?
Because right here the x squared terms kill each other.
Okay, and if they didn't,
Then I have to do it this way.
then we'd have to factor it.
Mm-hmm. That's the only reason we had to develop this new way is because my x terms are not like terms. I can't do it the way. Look here, where that 7x come from? My like term x stuff, right? So if I have a piece that's not like terms, I have to have a different way to do it.
Okay.
I like it. Okay, cool. So the next thing I want to do, real quick review of functions. Does somebody remember what makes something a function versus not a function?
I believe when you have a straight line.
What kind of line?
Linear.
There's some kind of a line test involved.
Okay, I know what you mean. So it doesn't
The same,
when you put a line.
So we have approximate knowledge of this. Okay.
When you put a line through it, you're not supposed to hit the line's not supposed to hit that line that you put through it twice.
All right, I like it. So let's figure out why that makes sense. Anybody ever watched something called Highlander? Anybody ever heard of Highlander?
Yes.
I heard the car.
You know, the guy that's got to chop the heads off and stuff, right?
Yes.
I'm into very violent stuff, apparently. That's why I teach math about killing each other and shit. The definition of function actually has a lot to do with the idea in that series or movie or whatever. Not the second one, the alien bullshit, but anyway. So the definition of function, really, to get to the crux of it, is for every input, there could be only one output. So for every input, of course, we normally consider inputs to be x. It could be other letters too, but to begin with, we think of them as x. Y equals mx plus b, that kind of thing. For every input, there can be only one output. And one thing that this would tell me, if this was true, that means that this thing can model a lot of real life situations. So if I threw a baseball and I said, okay, 2 seconds later, where is that ball? And you say 7 feet in the air and 2 feet in the air. I'm like, what the hell happened to that baseball? Right? Is there a freaking samurai like shove the minute I throw it? The two halves of the ball? I don't think that's happening. That'd be a really interesting take on baseball. But do you guys understand what I'm saying? So the input in that case was time. 2 seconds later, where's the ball? There can only be one output. There can only be one answer, right? If I say, what size shoe are you wearing on your left foot? There can be only one answer, right? Now you're like, let me put 2 shoes on my foot. No, come on. Are you guys with me a little bit? So one reason why we came up with this definition is because it's a class of things that can represent certain physical properties. You know, I can't be in 2 different places at one time. This definition, and of course the outputs are Y's normally, this definition directly leads to the idea of the vertical line test. Why is this not a function? Well, for example, for this input, there is more than one output. It goes to this Y, and it goes to this Y. Do you guys see that? So that violates the definition. So it's a shortcut then when I have a graph, vertical line test. If a vertical line goes through more than once, that's a visual way of not meeting this definition. Right? Now if I have a function, if I have a thing that every vertical line I can imagine does go through just once, then that's a function. Wow, that's a great check. This, not a function. Fails the volt, the vertical line test. Later we'll see there's a horizontal line test for something more interesting. But right now there's only the vertical line test to see if it's a function. This, not a function. If I threw a ball and it's here and below the ground, I'm like, there's a lot wrong with that. Right? How the hell did half of it get below the, what the shit's going on? All right, maybe. Also, if I gave it to you like this, for example, if I said, here's a function, or is this a function? Does this represent a function?
No.
No, and in fact, I want you guys, isn't this graph, this is a function, right? Isn't it a collection of points
Yes.
that I've connected? Well, here's a collection of points, but I just didn't graph, I didn't connect them. Why is this not a function?
The same has E.
Yeah, because an input of 1 has more than one output. Right?
Oh, okay, yeah.
It's like me saying, how old is person 1? They are 2 and 7. What the shit? Man, they're like phase shifting. Ah, who's you? So the shortcut when it's given to you as a graphical form is the vertical line test. When it's given to you as a collection of points, just see if any x's are repeated. Is this a function though? Oh, get out of there. Oh, get out of there. Rah. There.
Yes.
Yeah, why is that a function? Oh, I love my systems. Become a point. There you go. No x goes to more than one y. Do I care that this is 2? No. Okay, how high is that book off the floor? Like 3 feet. Let me wait several. Now how high is the book off the floor? Still 3. It's still an output of 3. It's a physical thing we just measured. So yeah, it's fine to have the same output. No input has more than one output. You can't say. All right. I just get amused by all the different reactions I get. So on this one, this sheet here, take a little break from factoring for a minute. Has everybody got this sheet, the function sheet? On the other side is that motivation for the freaky first number not a 1 factoring that we did a while back. All right, so everybody try these. Try these problems out. Yes, sir. Let me turn this off.